Hello everyone, this lecture video is going to be going over frequency distributions and their graphs. One way we can organize the data we collect is by using frequency distributions. Now there are three types of frequency distributions we could use. If we are working with nominal or ordinal level data, we will use what is called a categorical frequency distribution. But if we are working with interval or ratio level data, we will use a grouped frequency distributions if we're working with a large range of data, or we will use an ungrouped frequency distribution for smaller ranges. So let's jump into an example of each. So for a categorical frequency distribution. Let's say a researcher asks a class of 25 students their blood type and collects the following results. Excuse the weird, I don't know how to explain what that is, but the spacing of this is weird. But we get these results. So A, B, O, no pluses or minus, just main blood types. Okay, since this is nominal level data, since there's no order to these blood types, right? A is not above O, B is not above O is not above A or B or AB. They're just a list of blood types, right? And so this is nominal level data, which means we're going to be using a categorical frequency distribution. And since we only have 4 blood types here, A, B, O, and AB, those are going to be our 4 classes. So our first class is going to be A, our second class is going to be B, our third class is going to be O, and our last class is going to be AB. And that's going to be the first column in our categorical frequency distributions. Now notice I already had this drawn, but if you need to pause the video to draw it real quick, there are 4 columns when it comes to categorical frequency distribution. So first we determine our classes, that's our 4 types of blood type, and then next we tally, which means we're going to go through and count. We're going to go through and count, okay, how many type A's is there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, and as we could go through this, another way we could do this is tally it, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, next we're going to go through and we're going to count how many B's there are. And actually, let me move this up a bit. Okay, well, there's 1, 2, 3, 4, 5. Tally wise, 1, 2, 3, 4, 5. For O, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To tally it, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then finally, AB, there is 1, 2 AB types. Okay, and then we're going to put a number to this. So for class A, there are 8. This is called the frequency of that class, how many data values, not really values because it's not a number, but data points are in that class, and that's 8 for A, 5 for B, 10 for O, and 2 for AB. Okay, and then that makes us a total of, let's count. Well, 8 plus 5 is 13, plus 2 is 15, plus 10 is 25. That lines up with what we were told in our question, right? There are 25 students. Sometimes you go through and you do this, especially if you don't circle them like I did. I like to do this so I can see, okay, I've counted every single data value in here. If you're just tallying, you may miss something. And so make sure you go through and check that your frequency adds up to what your question told you. So all of these add up to 25. So we know we have that correct. Next column is percent. Now remember to compute the percent of a class, you're going to take how many objects are in that class divided by how many objects total and then multiplied by 100. So 8 divided by 25 multiplied by 100 is going to give us 32%. 5 divided by 25 multiplied by 100 is going to give us 20%. 10 divided by 25 multiplied by 100 is going to give us 40%. And then 2 divided by 25 multiplied by 100 is going to be 8%. And then, in addition to all of these needing to add up to what our question tells us, this percent should add up to 100%. And so if we count this, 32 plus 8 is 40, plus 40 is 80, plus 20 is 100%. So that does in fact add up. And that is all there is to creating a categorical. Hello everyone, I apologize for that a brief cutout in the previous lecture video. My screen turned off and so my video turned off. But let's go ahead and jump into a grouped frequency distribution. Now the first thing you're going to do is choose the number of classes you want. Oftentimes I'm going to tell you choose 7 classes, okay? So first you have to determine how many classes you need. Next you need to find the class width. Now this should always be an odd number. So if you get an even number exactly, you're going to want to round up to the nearest odd number. And if you get a decimal, you're going to round to the closest odd number. Okay, after you do that, you're going to set up your classes, which we'll do an example so you'll see what I mean by this. And the classes should not overlap. So if one class is 1 to 2, the other class should not be 2 to 3. That's an overlap, right? 2 and 2 overlaps. It should be 3 to 4. And now this is just a random example. Again, you'll see what I mean when we do an example. Classes will include all real numbers between the cutoff values, and the classes must be equal in width. Now, to determine what your class width should be, you're going to want to first find the range, which you're going to find by taking your largest data value minus your smallest data value. And then to find your class width, you're going to take that range divided by the number of classes you want, which, again, I will tell you the number of classes you need to make in your frequency distribution. Now, you're going to round up if it's even, just like I said earlier, and you're going to round to the closest odd number if we get a decimal. Class boundaries, it's going to go from the lowest value that would round up to the lower class limit, all the way to the highest value that would round down to the upper class limit, which is 1 decimal place more than the data is presented in. So let's say our class is 1 to 2, then the class boundaries would be 0.5 because anything greater than that will round up to 1, 2.5 because anything lower than that will round down to 2. And so these would be our class limits. So what I like to think is if we're working with whole numbers, it goes this minus 0.5, that gives us this, and then this plus 0.5, that gives us this number. However, sometimes you're working with decimals. So if our class limits is from 1.5 to 2.5, then this doesn't apply anymore, right? The minus 0.5 and the plus 0.5, you have to go to the next decimal place. So what next decimal place would be rounded up to 1.5? Well, anything above 1.55. And what highest value would round down to 2.5? Well, 2.55. Okay, so essentially just put a 5 after your highest decimal and after your lowest decimal. You just add another 5 at the end. So this should be 1.45. So notice, rather than minusing 0.05, rather than minusing 0.5, we're minusing 0.05. Rather than adding 0.5, we're adding 0.05. And if the class limits were 1.55 to 2.55, then the class boundaries would be from 1.545, right? 0.005 less than this guy. If you need help with that, just add a 0 right there, minus the 5 at the very end. And that gives you this guy, and then plus 0.005, which is going to give me 2.555. Okay, now in this lecture video, we're not going to work with decimals, and so if you're confused on anything I've said up to this point, make sure you're reaching out and getting help so that, when you get to class, you're not completely lost. Okay, now let's jump into an actual example. So let's say that a researcher finds the blood pressure of a group of 50 people and collects the following results. So we got all of these guys. Now, if we go through and we look at all these numbers, we will find that the largest data value is 134 right here, largest data value, and that the smallest data value is 100 right here. Okay, so that makes our range 134 minus 100, which is 34. And for this example, we're going to use 7 classes. We're going to want to split our frequency distribution into 7 classes. What does that make our class width? Well, to find the class width, we take our range, 34, and divide it by our number of classes, 7. That's going to give us 4 point something, and so we're going to round up to 5. Okay, and I think earlier I said round to the, well, never mind, that's not applicable. Scratch that. Okay, now we want to create our classes. Now our class limits are going to start at our lowest data value. So our lowest data value here, we just said, was 100. Okay, and then we said that our class limit is 5, our class width is 5. Now that doesn't mean we're going to add 5 to this. That means that our class should include 5 numbers. Well, 100's one number, 101, 102, 103, 104. That's 5 values. So our upper class limit is going to be 104. Then the next class is going to start at the next number, so 105. And then again, we're going to do the same thing, 105, 106, 107, 108, 109. That's 5 numbers. So our upper class limit is going to be 109. Now notice all we're really doing is adding 4 to each lower class limit. And that's because for the class width to be 5 means that the boundaries need to be 4 apart. And so from there, we can just notice the pattern. The next class is going to start at 110 and it's going to go to 114. Next class is going to start at 115. It's going to go to 119. Make sure that none of your limits are the same. If this is 104, this cannot be 104. If this is 109, this cannot be 109. They all have to be different. You should see a different number in each one of those spots. After 119, we have 120. Add 4, that's going to give us 124 is the upper class limit. And then 125 comes after 124. Add 4, that's going to give us 129. And then finally, 130 to 134. Now, when life works out really nicely, you're going to get that your classes start at your lowest value and end at your highest value. Sometimes there is a little bit of discrepancy there, and this may go 1 or 2 past your highest value, but that's okay. We're not going to worry about that. Now, if there's a class with that none of our data values lie in, that probably means you did something wrong. Like if we had another class here for some reason that was like 135 to 139, there wouldn't be any data values in there. So in that case, something went wrong. You need to try again. The midpoint of our class limit is going to be the middle value, which you can find by taking the lower limit, adding the upper limit, and then dividing by 2. Okay, for this first one, that's going to give us 102. And then from there, you can actually use your class width at this point. The class width is 5, which means the next midpoint is going to be 5 away from the previous midpoint, 107. If you're a little bit confused on that, again, just add 105 plus 109 divided by 2. That will give you 107. And then the next one's going to give you 112 because 107 plus 5 is 112. Plus 5 is 117. Plus 5 is 122, plus 5 is 127, plus 5 is 132. And if you are in this class, you will have a calculator, so you can always use your calculator. But if you're just trying to do this without a calculator, you can always just double check by looking here. Is 102 the middle value between 100 and 104? Yes, it is. Is 107 midway between 105 and 109? Yes, and so on. Now for class boundaries. Now remember what we said, we're working with whole number class limits. So in this case, the class boundaries are going to go from whatever decimal rounds up to 100 to whatever decimal rounds down to 104. Now anything greater than 99.5 is going to round up to 100. So that makes our lower class boundary for our first class 99.5. Anything less than 104.5 is going to round down to 104, so that makes our upper class boundary 104.5. For the next one, so for class boundaries, we will have an overlap because the number that rounds up, or the least number that rounds up to 105, is also 104.5. So our next class is going to start at the upper class boundary of the previous class. So our previous class went to 104.5, so our next class is going to start at 104.5. And then as we see, our upper class limit is 109. What rounds down to 109? 109.5. And then this is going to keep repeating. So the next is going to start at 109.5 and it's going to go to 114.5. I got 114 because it is the upper class limit. And then the next one's going to start at 114.5 and go to 119.5. And the next is going to start at 119.5 and go to 124.5. And the next one's going to start at 124.5 and go to 129.5. And then finally, the last one's going to start at 129.5 and go to 134.5. Now for frequency. Now this is going to be a little bit more difficult the more data values there are. So what I like to do is I like to circle and mark. Now notice there's not a tally section. We're just going to go through and count. So in this first class, the frequency is going to include how many data values are between 100 and 104. So let's go and count. Well, here's 100. The next one we see is as we go down the list, we come no 104, nothing less than 104, nothing less than 104, nothing less than 104, nothing less than, oh, here's a 104. That's also going to be included in that class. Keep going, nothing less than 104, nothing less than 104. And so in this first class, we're going to have a frequency of 2. In the next class, we're going to go through and count all data values that we haven't already circled that are less than 109. That's how I keep track. Okay, so we circled this one, so we don't have to worry about it. Anything that we see that's already circled, except for this 134, as this was used to find the range, we're going to keep into account those, and we're just going to look for the ones that are less than 109. Okay, or equal to, less than or equal to 109. Okay, well, there's 105, 1, 109, 2. Keep going down our list. We don't see any. We don't see any. Oh, here's another one. 3. Here's another one. 4. Another one. 5. Keep going down your list. Keep going down your list. Another one. 6. Or you could just go through and circle and then count. Either way you want to do this. Here's another one. 7. Keep going. Keep going. Keep going. Keep going. We already circled this one, so we don't have to worry about it. Oh, 105. There's another one. That's 8. Keep going, none in this last row, so there are 8 in that second class. Next, we're going to look at everything we have encircled that is less than 114. So we come through here, we say, oh, 112 is less than 114. 110 is less than 114. 112 is less than 114. 110 is less than 114. 114 is equal to 114. Same there and same there. 112 is less than 114. 114. Keep going. 110 is less than 114. 110 is less than 114. 113 is less than 114. 111, 111, 113, 110, 112, 114, 114. Now notice, I knew this was going to be a large class because obviously I've already completed this problem, but I didn't go through and I didn't count while I was circling because me personally, I get confused if I try to count and circle a lot of things. So now that I've circled all these blue values, I'm going to go through and count them. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So class limits 18. Or excuse me, the class frequency is 18. All right, next we're going to look at all values less than 119 that we have encircled. So we start here at 118, 118, 117, 116, 118, 115, 118, 117, 118, 116, 119, 118, 117, and that is all that is less than 119. So now let's go through and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the class frequency of that fourth class is 13. Now for the next one, we're going to circle all values less than 124. So we have 120, 122, 122, 121, 120, 120, 120. So that leaves us 1, 2, 3, 4, 5, 6, 7 in that class. In our next class, we're going to circle all data values less than 129. Notice we only have one data value that's not circled, but keep in mind we haven't actually used this 134 when marking the frequency. So there's only one in the next class, one that's 127, and then there's only one left, which is 134, which belongs in the last class. Now, oftentimes, especially with large data sets, it's easy to miss something or miscount. So what I like to go ahead and do is make sure these add up to what our question told us. So we asked 50 people. So this frequency should add up to 50. So 8 plus 2 is 10, plus 18 is 28, plus these two is 30, plus 13 plus 7 is 20, 30 plus 20 is 50. So all of these do in fact add up to give me 50, so we are good. Cumulative frequency is going to build on each class. So our first class only has 2 in there. So the cumulative frequency up to that point is 2. But the next class, we have 8 more data values in that class. So at that point, our cumulative frequency is 2 plus 8, which is 10. And then next, we start with 10, we add 18, that's going to give us 28. 28 add 13 is going to give us 41. 41 add 7 is going to give us 48. 48 add 1 is going to give us 49. 49 add 1 is going to give us 50. This last number should be equivalent to how many data values you have. Last but not least, relative frequency. That is similar to percent, except we're going to leave it as a decimal. So relative frequency is like the percentage that's in that class of data values that's in that class, but instead of writing it as, 20%, we're going to write it as 0.20. And it's found the same way we found percent, but minus that times 100. So for this first class, we're going to do 2 out of 50. That makes our relative frequency 0.04. For the next class, it's 8 out of 50, which is going to make our relative frequency 0.16. Then there's 18 out of 50, which is going to make our relative frequency 0.36. Then we have 13 out of 50, which is going to make our relative frequency 0.26. And then 7 out of 50, which is going to make our relative frequency 0.14. And then 1 out of 50 is going to give us 0.02. And the last one is also 1 out of 50, 0.02. And then since we're not working with percentage, this shouldn't add up to 100%. Instead, it should add up to 1. So 0.4 plus 16 is 0.20, plus 0.36 is 0.56, plus 0.26 is give me a second, I'm doing this in my head, 0.82, plus 0.02 is 0.84, plus 0.02 is 0.86, plus 0.14 is in fact 1.00. So that also works out. We know we have created a correct frequency distribution. Okay, now I wrote out in words everything that I've said as we've gone through this. So you do have access to these on Blackboard. So if you need to go a little bit slower, feel free to go back and rewatch this video, but also feel free to go through and read this, as if you're more of a word person, if you can read the words, you'll understand what you're reading, then that you have that as well. Finally, the last type of frequency distribution we're going to work with is an ungrouped frequency distribution. So let's say we have a researcher that collected the data of the age of 20 dogs in an animal shelter and found the following. So we have 5, 8, 7, but look at these values. They're all pretty close together. The highest value here is 9 and the lowest value is 3. That makes our range 6. Now, anything that is between 1 and 20, if any range between 1 and 20 means that each class can have its own data value. Okay, so each data value gets its own class in this case, since that range lies within the number of classes that we can have. Okay, so one class is just going to consist of the data value 3. The next is going to consist of the data value 4, 5, 6, 7, 8, and then 9. So each data value in our class gets its own mark. Okay, next we're going to go through and tally. So we have 1 3 here. We have another 3 there. So there are 2 in that class, making the frequency 2. Next for 4, we have 1, 2, 3, 4. So there are 4 in that class, which makes the frequency 4. For 5, we have 1, 2, 3, 4 again. So 1, 2, 3, 4, making our frequency 4. For the data value 6, we have 1, 6, so making our frequency 1. For 7, we have 1, 2, 3, 4, making the frequency 4. For our 8, we have 1, 2, 3, making our frequency 3. And then for 9, there is 1, 2 left. Again, if you're doing what I do where you circle the largest number and the smallest number, make sure you don't forget about those 2 numbers. We haven't actually used that when computing the frequency, so we still have to keep those in mind. So the last the last class has 2, and so that gives it a frequency of 2. And I didn't write the previous one. And then percent, it's the same thing as before. Now, we're already told that there are 20 dogs, but again, sometimes we miss something. And so we want to go ahead and make sure these all add up to give me 20. 2 plus 4 is 6, plus 4 is 10, plus 1 plus 4 is 15, plus 3 plus 2 is 20. So this does, in fact, add to give me 20. And then for percent, we take the frequency of the class divided by the total number of data values, and that's going to give us the percentage of data values that lie within that class. So 2 out of 20 is going to give us 10%. 4 out of 20 is going to give us 20%. Again, the next one's 4 out of 20, so again, 20%. Then we have 1 out of 20, which is going to give us 5%. And then again, 4 out of 20, which we already determined is 20%. And then 3 out of 20, which is going to give us 15%. And then 2 out of 20, which again is going to give us 10%. And just to check our math, we want to go ahead and make sure that all of these add up to give me 100%. So 10 plus 20 is 30, plus 20 is 50, plus 5 is 55, plus 20 is 75, plus 15 is 90, plus 10 is 100. So it does in fact add up to give me 100%. So I know this is an accurate frequency distribution. All right, that is going to be the end of this first lecture video. In the next one, we're going to look at frequency histograms, which is going to be a picture that relates to our frequency distribution.